In this lesson, we're going to take a look at the dynamic simulation properties, including gravity, viscosity, friction, and dampening. So this time, I'm going to actually use a shelf button to create my container and emitter. So I'm just going to use this one right here, which is part of my fluids shelf. If you haven't loaded that, you're more than welcome to use that to generate your containers and follow along in these examples. All right, I'm going to rewind and hit play. And essentially, we're going to leave everything default. I do want to talk about, let's close display, these dynamic simulations. You have a gravity attribute. Now, essentially, a lot of people, if they want the fluid simulation to fall to the ground, they'll set a negative gravity. So I put a negative 9.8 for the gravity. Here's a problem. Yes, the fluid falls, but everything in the system now thinks that we have negative gravity, and that's not true. We don't have negative gravity. We just wanted the particles to fall. So if you're needing to have the particles fall to the ground, set the particles to have a buoyancy that's negative. Okay? Right now, we have a positive buoyancy, which means it's floating to the top. So I'm going to pause right here. I'm just going to scroll down to where it says Content Details, and there's one for density. I'm going to take this buoyancy and set it to -1. Now, if I hit play, my particles fall to the ground, but my gravity is normal inside of my system. And that's really important. Sometimes it's easier just to change gravity, but don't. You know, there's other ways of doing that. Okay? So let me set this back to 1. And we'll come back and talk about some of these attributes here in just a second. Now, viscosity is really, if you had to think about this, it'd be like the difference between water and coffee, like that type of a liquid, to honey, something that's very thick and gooey. So the more I increase this viscosity, it's essentially calculating the resistance that it's showing as it moves the particle or flows the particle. So let's rewind and play this. Okay, and watch what happens as I crank this up. See how it's slower, it's gooier. It's almost like it's thicker. All of these settings, of course, if I set this to 1, it's so thick it's not even moving. Okay? So, something to think about as you're adjusting these settings. Now, friction is essentially just like you would in any other force. It's the friction that it's facing as it's moving forward. Now, if I increase my viscosity, I get a very gooey material that is having a hard time moving, and you can see here how thick, it didn't hit the edges quick. Okay? And my dampening is the amount of energy that this is losing as it's moving. Okay? So you can see here that I am losing energy, it's thicker. So if I had to simulate something like a drip or some liquid falling, in this case rising, but some liquid falling, I would put a negative buoyancy and then let it just kind of ooze. And again, later on, I'll show you how to actually create textures with these types of containers, so you can actually create that type of a gooey texture from the system. Now, there's a number of solvers that you have access to, the spring mesh and the Navier-Stokes. The issue with spring mesh on a 2D container, it's really best for things that are moving in and out, like a ocean or a pond. So Navier-Stokes is the best way to go, unless you've written your own. The high detail solve, again, you can increase the quality. Let's say I turn this on for all grids. It's going to calculate a little bit slower. It's going to try to give me a much more accurate. You can see here, these got these nice trails, but it is slower. So anything inside of fluids, the higher the quality, the slower it's going to be. Okay, so I'm going to set that back to off. I do have a quality here. So again, the more I increase this, essentially what it's saying is calculate 78 steps per frame as we go through this. So again, the lower this number, the faster it's going to solve. There you go. Now, if you want the ultimate in high quality, okay, so let's set the solver quality high. We would set this to this high quality or high detail solve. I'd go ahead and turn on any of the grids, so we'll just calculate the density, so all grids except velocity, and I would change my grid interpolator from linear, which is essentially a straight line, to Hermite. And what this is going to do is really give me the formula for a very, very accurate simulation. Again, much slower, but the quality is going to be higher. All right, one thing that I do want to show you is this start frame. Let's say we don't want the simulation to start until frame 100. Well, I'll just put a 100 in there, rewind, hit play, and you saw how it ran to 100 and then the simulation started. So if you know you need an offset, let's say the character's out of the way, they're holding a cup of coffee and you've got an animation in the cup, you don't really see that animation until a certain frame where they put it down and you want to start the simulation right before they put it down, you can offset that here. You can also set the simulation rate scale, and this is essentially a time multiplier. So as you're going through and doing the simulation, what happens is if I set this to 2, watch what happens to my simulation just by setting that. See how much faster that's moving? Let me set this back to 0. Okay, let's actually set the rate scale to something like 5. Oops, one. And I'm going to reduce my viscosity and friction quite a bit too. There we go. So that's a rate scale of 5. Let me go ahead and set this back to 1. So that's 1. And here's 5. Okay, much faster. Again, leave it at 1, run the simulation. If you need to increase the speed of the overall simulation, you're happy with the way it works, you can increase the simulation rate scale, but, you know, if you need to have it go twice as fast, fine. If you need to go 5 times as fast, probably need to rethink how the simulation is set up and make the simulation itself move a little quicker. Now, let's say you're happy with everything, you got everything cached out, you can just disable this evaluation. And now when I hit rewind and play, nothing. My timeline moves just as fast. The system is not calculating this. Now, if I turn this back on, the system is going to have to catch up where it is and try to, it's just going to break. Now, I've got this sucker set to all the way high quality, so let me set everything back to default quality. There we go. The problem is you can't key this on and off, and even if you could, you wouldn't want to then turn it back on, because it'll break the particles just like you saw there for just a second. So you want to be careful of that. Lastly, we're not going to really get into any of these, the conserve mass, use collisions, use emissions, use fields, because I usually leave them all on by default. Most of the times I'm wanting a collision, I'm wanting to have emissions. If I have a field, I want it to use it. If I didn't want it to use it, I wouldn't have the field in there. But if you do have a field inside of your simulation, you can go ahead and turn it off here, and you can, control that individually. Okay.